Hey, welcome to your Regents review video for level 1. We're going to be going over the most important topics that you learned in this level on transformation. So let's not waste any more time. Let's just get right on into it. First, and the most important topic that you learned about was the difference between a rigid motion and a non-rigid motion. Now remember, a rigid motion would be a translation, a reflection, or even a rotation. These are the three kinds of rigid motions that we learned about. And remember, rigid motions preserve the side lengths and the angle measures, meaning they do not change. All right? And for that reason, whenever you use a translation, reflection, or rotation, the image is always congruent to the pre-image, right? Because the sides did not change. So these three are rigid motions and they produce congruent images. Now, non-rigid motions, we only learned about one, and that's a dilation. Dilations are non-rigid motions. Non-rigid motions. And remember, while they do not preserve the side length, they do preserve angle measures. So we do know the angle stays the same when we dilate something. So we get similar figures. So these two triangles would be similar. Remember, angle similarity, but they would not be congruent. So, rigid motions, non-rigid motions, those are big concepts. Also, the two things you should remember is one, the minimum rotation formula is 360 over n is the amount of sides in the shape. So if I want to say, hey, I have a triangle, what is the minimum rotation for that to look exactly the same? We would do 360 divided by 3, right? Because it has 3 sides. That would give us 120. And that is the minimum rotation for that. And then we have scale factor. To figure out the scale factor of a dilation, we use K equals image over pre-image, and we'll do examples of that today. All right, let's move on. So the first kind of skill that we're going to need is how to describe a transformation. So what we're looking at here in this problem is a transformation that's already occurred. And what it's asking us to do is describe it back to them. And remember to use very specific language when you do this. So on this first one, it says the graph below shows triangle ABC and its image A double prime, B double prime, and C double prime. And those double primes mean there's two transformations, right? Because there's two primes. Transformations, okay? Describe a sequence of rigid motions which would map triangle ABC onto A double prime, C double prime, A double prime, B double prime, C double prime. And remember, a sequence also tells us that there was more than one transformation. Now, as I told you, there's an infinite amount of possibilities you can come up with. The way I'm going to do it, well, first I'm going to start with a translation 2 units down. So we're going to go 2 units down, 1, 2. And remember, if you go 2 units down, all your points go 2 units down. So B goes 2 units down and A goes 2 units down. So our new triangle would look like so. And that'd be A prime, B prime, C prime. So we're going to start first. A translation 2 units down. And then what we're going to do is we're going to do a reflection. We're going to reflect over y, this is the y-axis. And the reason we can do that is because both of these are 2 units away from the y-axis. So they're perfectly symmetrical from there. So then a reflection over the y-axis maps triangle ABC onto triangle A double prime, B double prime, C double prime. And that's all you got to do. Now, the main things I want to point out about how I answered this question is, one, when I said a translation, I was very specific. I said 2 units down. I didn't just say a translation. I said a translation and how much I moved it. And then whenever we reflect something, we always talk about the line of reflection that we used. All right, let's move on to our next question. So if we go to this first one right here, once again, we're going to describe this transformation. So this one says, in the diagram below, triangle ABC and XYZ are graphed. Use the properties of rigid motions to explain why triangle ABC is congruent to XYZ. Now we could do that by just mapping them onto each other. Remember, So to use the properties of Regents to explain why they're congruent, we have to map them onto each other, and then we have a very specific sentence we're going to say. So how can we get these to map onto each other? There's many ways to do it. I'm just going to do it using a rotation. So if we rotate ABC 180 degrees around the origin in a clockwise rotation, then we're going to map them onto each other. Now remember, when we talk about rotations, we need three things. 1, 2, 3. We need the direction we're going to rotate in. We need the amount of degrees. And we need the center of center of rotation. We need all three facts when we talk about rotations. So now let's write it out. So a rotation, 180 degrees, clockwise, around the origin, maps triangle ABC onto triangle XYZ. And then the next sentence, you might remember this. The question says, explain why they're congruent. All we have to say is this: a rotation is a rigid motion, and rotations and rigid motions preserve side lengths and angle measures. Done and done. So just remember, if it ever says use the properties of rigid motions to explain why they're congruent, we always add this little sentence in. We know they're congruent because rigid motions preserve side lengths and angle measures. So in the last two problems, we were describing transformations. Now we actually have to do transformations. So the first one says triangle ABC is graphed on the set of axes below. Graph and label triangle A prime, B prime, C prime, the image of ABC after reflection over x equals 1. So remember, x equals 1 is a vertical line. Okay? And so we just go to 1 on the x axis and we go right through it like that. So that would be x equals 1. All right? Vertical line for x. Y equals is horizontal. Now we just count how far we are from this line. So B is 1 unit away, so we go 1 to the other side, and that's where B prime is. C is 1 unit away, so we go 1 unit to the other side, and that's where C prime is. And then A is 1, 2, 3, 4, 1, 2, 3, 4, and that's going to be A prime. And so all we do is draw it out now. Boom, boom, boom. Done. So this says graph and label. I've done this perfectly. I've graphed the points correctly. I made sure I put my primes there. Primes are super important. It does not say state the coordinates, so I won't do that. And that's it for this question. And then for our final question, we're going to draw a transformation. Oh, this is a describe. Describe a transformation that maps triangle ABC onto ADE. So this is our ABC, and that is our ADE. So since it's getting bigger, obviously it is a dilation. So remember, for a dilation, there's two things we need to write about. For dilations, you always have to talk about 1, the scale factor, and 2, the center of dilation. Now the center of dilation here is easy. It's the point that everything's moving away from. So right here, A is your center of dilation. See how all the lines are moving away from that? So that's easy to do. So we could say a dilation centered at point A. Now we have to find out the scale factor. The way you do that is by counting how far each of these triangles are from the center of dilation. So for example, point C is 1, 2, 3, 4 to the right, and then 1, 2 up. So it's 4 and 2. Now to get to point E, we'd have to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 over, and then 1, 2, 3, 4, 5, 6 up. All right? Now, if you take those numbers, you might remember to find out our scale factor, we just do the image over the pre-image. Since ADE is the image, the result of the dilation, we can just do 12, which is this length, over 4, which is this length. 12 divided by 4 is 3. So remember, this got 3 times as far away. Okay, so we have a dilation of 3. So back to our sentence, a dilation centered at point A with a scale factor of 3 maps triangle ABC onto triangle ADE. All right, guys, that's it for our level 1 Regents review. Remember, this is the most major topics. There's many more kinds of questions that you'll encounter, but these are the major ones. You need to be able to describe transformations and do transformations. All right, so that's it for this video. Yeah, go kiss your mom, kiss a cat. If you don't own a cat, buy a cat and make the world a better place. Peace out.